Hello everyone, now we are going to see about common source stage with degeneration. In the previous videos we have discussed about common source stage and common source with diode connected load, common source with current source load. Now we are going to see about common source stage with degeneration. So if there is no diode, this is equivalent to common source stage. So common source means what? At the gate side we are giving input, at the drain side we are taking output. Source will be act as a common terminal for gate and drain. So this will becomes common. So we are connecting source to ground. So when you are taking degeneration circuit, that at the source terminal we have to add one resistance, that is RS. So this is what the common source stage with degeneration. This is what equivalent small signal model circuit. Here at the this is my gate, drain and source. At the gate side we are giving input, and between gate and source we can measure the voltage V1, and source here we have added one source resistance, so we should draw that RS. So at the source side we are having one source resistor that is connected with ground, and at the drain side we can measure the current. So what is the current value? That is GMV1, and we are having one load resistor, that is our drain resistor RD. This is the small signal equivalent diagram. So what will be the, for this using the small signal model we are going to find what is the gain voltage. Here when you are considering bipolar transistor, that is common emitter with degeneration, so there also at the emitter side we are having one resistor value. So if you are adding this degeneration, see when you are considering this degeneration, you are adding one resistor at this source side, what will happen? Your input output impedance will be changed, gain and linearity everything will be changed. So input output resistance, gain, linearity everything is going to be changed when you are adding source resistance at the that is RS at the source side. So now we are going to consider channel length modulation is 0. So lambda will become 0. What is your gain? This is what we are going to find now. For finding voltage gain, we should need output voltage and input voltage. So what is your Vin? Vin is equal to, here you can refer this diagram. So Vin is equal to V1 plus voltage at this side. So voltage at this side is V equal to I into R, or RS. V is nothing but this, I nothing but GMV1. So your input voltage that will becomes V equal to V1 plus GMV1 into RS. Here I am taking V1 as common, so V1 into 1 plus GMRS, this is your Vin. Here you can also measure what is V1. V1 equal to Vin divided by 1 plus GMRS. This is what about input voltage. Then next we are going to find what is our output voltage. Since GMV1, that is current, this current flows through this RD. So GMV1 flows through RD. What is my output voltage is V equal to I into R. Here the current is in opposite direction, so V out equal to minus, that is represented by negative sign. So V equal to I into R. So minus I is nothing but GMV1. So I into R, at the output side I am having RD as the resistance. So this is my output resistance. So here to find AV, we are having V out and V in. So what is the formula for finding AV? AV equal to V out by V in. You can substitute V out value and V in value. So V out equal to minus GM V1 RD divided by, what is your V in? That is equal to V1 into 1 plus GM RS. Here we can cancel V1. So finally we will be having V out by V in equal to minus GM RD divided by 1 plus GM RS. Here I am taking GM outside. So we will get GM into 1 by GM plus RS. We can cancel GM because both are in numerator and denominator I am having GM. So we can cancel this GM. So finally I am getting AV, that is equal to V out by V in, that is equal to minus RD divided by 1 by GM plus RS. This is my voltage gain equation of common source stage with degeneration circuit. So in this stage, in this common source stage, we have found what is the gain equation AV. So thank you for watching.